we want to find the derivative of e to the x. Well, we can do that using the power series definition, right? Remember that our function e to the x is equal to the power series of 1 plus x to the first over 1 factorial plus x to the second over 2 factorial plus x to the third over 3 factorial plus x to the fourth, right? Seeing the pattern, and then that just keeps going and going and going till infinity. We can find the derivative of that using the power rule. Derivative of 1 is 0. Derivative of x to the first over 1 factorial. Well, 1 factorial is just 1, so I'm going to take this 1, drop to the front. Well, that's just 1. Using the power series, I'm going to drop the 2 to the front here, and I'm going to have 2x to the 2 minus 1 over 2 factorial. And then plus, take the 3, bring it out front, 3x to the 3 minus 1, which is 2, over 3 factorial, plus 4x to the 4 minus 1, which is 3, over 4 factorial, and pattern continues. Now we can simplify this up a little bit. 0 goes away. 1 plus, well, when we're looking at 2 factorial, that's the same thing as having 2 times 1 in the denominator. So then the 2's would cancel, and I'm just left with x to the first over 1 factorial, which is just 1. Well, same thing's going to happen here. That 3 factorial is going to turn into 3 times 2 times 1. Well, the 3's would cancel, and now I'm just left with 2 factorial plus x squared over 2 factorial. Then, same thing happens with the 4. The 4 is going to cancel, and we're just left with 3 times 2 times 1, which is 3 factorial. X to the third over 3 factorial, and that pattern continues, right? So notice this looks exactly the same as this, and that's because they are exactly the same. The derivative of e to the x is just equal to e to the x. I think this one's my favorite one. Easiest to remember.